Again, can we start? Yes, okay. Good morning again. Second part of the IODP media conferences. This time it's on the future on ocean research drilling. Before we talk about the future, we should think of the past a little bit, because scientific ocean drilling started more than 40 years ago with the groundbreaking expeditions of the Glomar Challenger. And I just learned this morning, Catherine, that you were on the Glomar Challenger in the 70s, I think it was it a long time ago? So both of our speakers today can look back to a long and very successful career. But just to commence, the Glomar Challenger was, so to say, the star. Then we had the deep sea drilling program at that time, followed by the ODP, the ocean drilling program, and now we are in the phase of the integrated ocean drilling program, which started in 2003 and will end in 2013. There's not much time left, and now it's time to think about the future of ocean research drilling. And the two colleagues would like to inform you about the current process and ideas of the future. So I would like to introduce to you Catherine Mevel. She is from Paris. Catherine is director of EMA. EMA stands for ECORD Managing Agency. And ECORD, as I explained a little bit earlier, is the acronym for European Consortium for Ocean Research Drilling. So I would say literally our finance minister, maybe, something like that, but even more, of course.
Yeah, I think it's more than that.
Yes, I know. But we talk about money here too. So, yes. I'm very proud to also present to you Kiyoshi Suyehiro. He's the president of IODP. He became president last year. And in his long and really outstanding career, he graduated from the University of Tokyo, was in the US, then went back to Japan. And in the last years, he changed his life, his professional life, from being a pure scientist to becoming more and more a manager. You were associated with the program very much and became the president and CEO in 2009. And Kiyoshi will start, I think, taking a brief look back before we look into the future. The floor is yours.
Thank you, Albert. Okay, I would like to use the slides to briefly explain how we have been doing so far in IODP starting in 2003. I just want to briefly make 2 points. One is that what is different for IODP from its predecessors. IODP saw 2 additional new drilling capabilities, which are what we call MSPs, mission-specific platforms that the Europeans are providing, and the CHIKU riser drilling vessel, which is being provided by the Japanese. So these are new capabilities that really made the change from previous drilling programs. And by those introductions, we've expanded the targets of science. For example, by MSPs, which Catherine will elaborate on later, we can now drill in the Arctic ice, we can drill through coral reefs, we can drill in very shallow waters, and by the use of riser drilling vessel, we can drill very deep. And it has not happened yet, but within this IODP program, CHIKU is planned to penetrate the seismogenic zone at 6 or 7 kilometers below the sea floor. And that is where the seismic fault that generates magnitude 8 earthquake is. So that's something very new, and we have to be very careful in planning to make these capabilities to work for the best of the science. And the second point I would like to make is that these new changes is actually posing challenge to the science community, and fortunately our science community is adapting to the new opportunities from these new capabilities. And one unfortunate circumstance is that due to the rise in cost, unexpected rising cost from various reasons, we are not getting ship time year-round for these ships. However, in view of these enhanced capabilities, we are trying to be very innovative, creative, and so I just written some ways of getting the most out of these within this limitation, that we do multiple expedition projects, we perform multiple platform science, and we put in multiple objectives into expeditions. And those are the things we are trying to do to be innovative. And just to make a point here, over the last 40 or more years of ocean drilling, I think roughly about 2,000 sites have been drilled. And the point I want to make here is that what that amounts to on the average, sort of area-wise, if you do a simple calculation, that amounts to about 60 holes in the area of the size of Europe over 40 years. So it's a slow process, and it's slow, but I think it's necessarily slow because over the years, scientists and engineers have been developing new technologies so that more precise science can be performed, and that is still ongoing, and it will go on for many years to come, and it should, as we need to certainly drill into more spatial areas as well as deeper into the depth. I mean, if it's technologically possible, we would want to drill through the core, 6,000 kilometers. We laugh today, so, but we don't know. Another aspect that I want to emphasize is that the fourth dimension, the time series, is something that really scientists would like to get. And again, since ODP time, actually since DSTP time, there have been many experiments trying to get long time series, and we are in the process of bettering such efforts. And this is my third slide, and the overall direction, thinking about post-2013, the fundamental questions we ask are, who are we? And where do we go? And this can sound very philosophical, and perhaps 20, 30 years ago, it could have been just philosophical, and scientists could have been asking these questions out of curiosity. But nowadays, that's a luxury, and we are very much accountable to the public who are financing us, and these questions are important philosophically and in very practical sense to let the policymakers understand what the science is pointing to. So we need to have strategies, more refined strategies to make the best of our available capabilities. We are doing our best now, but we must even do better. And the Earth is a planet in the solar system, and we tend to, as you drill in certain local areas, you must focus your thinking into your local area, but you at the same time need to keep your planetary perspective of Earth and life, how they evolved together. And so that kind of perspective will be more and more become important post-2013. And I just want to emphasize some of the new challenges that I think could become very important is Chikyu, the riser vessel, will have to drill deeper. We envision that in the next 10-15 years, we will be penetrating the whole ocean crustal thickness and reach into the mantle. And if you reach the mantle, it no longer is ocean. It's the Earth. And then observatories need to become more standardized, and in order to see the Earth as in a planetary holistic view, you need to enhance more cross-disciplinary studies. And these are the things I think would become important to consider in post-2013.
So I will take over now and tell you a little how we are, what we are doing to develop a new science plan for the new phase of ocean drilling. And this started last year, actually, in Vienna. After the EGU conference, we organized a workshop which gathered about 80 people, 80 participants. And we developed a first draft of a European science plan that later on was merged into an international conference, INVEST, which took place in Bremen last year in September. And then we had 600 participants from the whole world. And the aim of this conference was to identify urgent questions in understanding the Earth system. But also, I insist on that, its interaction with humankind. And this is something that the past program were not so aware about. They were more focusing on basic science. But now we understand with what is happening now on the planet that we do interact. And it's really important to understand how. And this is one thing we want to investigate in the next phase. So following INVEST, a committee of 14 prominent scientists has been appointed to distill the discussion of INVEST into a focused science plan. This is happening now, so actually the committee will meet again in May, I think. So I cannot tell you much about what they are going to say, but I have a few points that I want to show you. Among the few points that came out of INVEST, they want to concentrate on the polar amplification of climate sensitivity, ocean acidification and its ecological impacts. And this is really important to understand the climate changes. We also want to investigate the deeply seated microbe populations, and it might have some development in biotechnologies. Of course, we are still interested in the Earth in motion, the deforming plate boundaries, fluid flow. And again, I insist on what Kiyoshi just said, active experimentation to get long time series and better understand active processes. And of course, these have a big relationship with geohazards like earthquake, slope failures, and all that. And finally, one new and interesting topic concerns the relationships between human evolution and climate. And my last slide is again to emphasize that ECORD, the European Consortium, has played a unique role in IODP by providing access to these mission-specific platforms. And you see here the 4 platforms which have been used by us so far. And the beauty of that is that now we can investigate new environments like ice-covered area, and the expedition in the Arctic was a great success. Coral reef, the New Jersey platform that you probably heard about with Jean-Noël this morning. And ECORD is really aiming to continue providing this capability in the new phase and open new frontiers. Thank you.
Would you like to add, Kiyoshi?
No.
No, okay. I think at one point during this process of discussing, we should just say that you pointed out in May there will be a meeting. And I think the first draft of the plan will be available by mid of June, I think.
Yeah, by mid-June we should have a first draft of the plan. Yeah.
Which then will be discussed openly in a democratic way. I think we should look into the future a little bit, I think.
So
can you point out what will happen until 2011, maybe?
That's the process. Eventually, we want to finalize the new science plan by next year. But until then, as Albert said, we will go through very democratic grassroots way of finalizing the document and ask for comments. And I think in the first draft, all the necessary ingredients will be there, but we would like to make sure, and also we would like to know where the focus should be. So we will ask the whole very wide worldwide community. I mean, the IODP is now being supported by 24 countries around the globe, and we would like to even expand the members. So we really want to make sure that the new science plan engages as wide as possible science communities.
Yeah, it's worldwide movement, so scientific movement, one should say. I mean, the core country is core participants, as I mentioned earlier, Japan, the US, the European consortium, including Canada, and associated members like India, South Korea, China, Australia, New Zealand. So it's expanding, and I think that's a good sign. On the other hand, I would raise one other point. As we are sitting here, we are maybe looking forward to an age where we come to our pension age, so to say. How about involvement of younger scientists? I mean, you have to raise the new generation, don't you?
We certainly do, but the Invest conference on that topic was excellent because it was a very mixed audience with experienced senior scientists, but also a lot of young scientists came and participated in the debate. And it's very important for us because they will be the one who will actually accomplish the science in the new phase of the program.
Yes, I agree. I mean, we do have to engage the upcoming generation of scientists, and I would like to really emphasize that if you're a scientist, you don't have to know anything about drilling. You have to be a scientist and be curious about how Earth and life evolved and pose good questions, and then we can tell you what the drilling capabilities can bring to you. So I think we really would like to expand the science horizon by bringing in new disciplines, new breed, and very honestly speaking, because of the limited time for drilling that we've been having over this 10 year, there are a lot to be done in the next phase, and we have, fortunately or unfortunately, time to think. So we really would like to ask anybody to come up with great ideas, exciting ideas, and I think we can respond to that.
And again, the website iodp.org is then the forum on which this discussion will take place, as it will be doing on other websites. So let's open the floor. Maybe you have any questions to the speakers. Are there any questions online coming in? Did you just check that? Oh, okay, good. So is there anything you want to know? Take the opportunity and use the microphone. Okay.
Could you please show the last slide again with the future rough priorities?
This one?
This one, yes, yeah. Thank you.
What is the budget of the IODP?
IODP is basically, in the present scheme, it's roughly about 120 million per year, but it very much depends on the months of operation of each drilling platform. And currently, the US Geosciences resolution operates about 8 months a year. Japanese Chikyu about 5 months a year, and mission-specific platform every other year.
Yeah.
Every other year, and that, if we assume that sort of schedule, it's roughly about 120.
You were talking about expanding the science communities who are participating and expanding the goals. But what about the means you have at disposal? Do you expect that you will have more ship time or more platforms which drill to perform all these tasks?
Of course, that's a very good question, and I think you have to take choices. I mean, you have to put priorities by the scientific community's efforts and do the best. And that means you cannot do everything.
But it's also, when we say we want to attract new communities, it's not necessarily to go on board the ship, but also to understand that they can use the data that we produce for modeling, for instance, or for other activities. So it's more that people realize that the unique data which are brought by the drilling program can be of benefit to them.
Yes, I think that's a very good point. And if you see the fact that even the lunar rock samples that were brought back many, many years ago are still bringing in new results, I think the core samples and that long-time series from the observatories will be very good resources for scientists to work on for many years to come.
All right. Any more? I think this is not the case. So if you want to talk to both colleagues personally, you're invited to. Otherwise, I would like to thank you very much for taking part. And the final media conference will take place in roughly half an hour. It's about the just recently finished Great Barrier Reef expedition. So hope to see you then. Okay, thank you very much to both of you.